Okay, so your 1.1 functions and continuity is what we're doing today with your domain and range. We know the domain is the set of x values, and that means that it is what you can plug into the function. So as a reminder, we're just going to write that this is the input. Okay, and then the y values are going to be the output. And I guess that means values, the x values and the y values. All right, and then a one-to-one function. So a function is called one-to-one if you have an element in the range paired with exactly one element of the domain. Okay, and then we can check this using the horizontal line test. Not if that sounds familiar, even if you don't know what it is. Horizontal line test, something that we've heard of. Okay, so some of you are nodding yes, but some of you are looking a little confused. So when you're doing the horizontal line test, if you can draw a line and it intersects more than one point, it is not one-to-one. Okay, so the horizontal line test is if it intersects more than one point, it's not one-to-one. And we're just going to shorthand one-to-one like that. Okay, so anything I'm writing down on my sheet, you're going to be writing down on your sheet as well. For the first few sections, especially, you're going to be relying on your notes to help you with your homework because the book asks you to do more than what I'm going to ask you to do. Okay, so you're going to be following your notes along with your homework. Okay, so for example 1, it says identify the domain and the range in each graph. And then you're going to write your solution in set builder notation. And I'm just going to write follow these directions. And we're going to look at the directions together today for your practice problems because you're going to see they're a little bit different. Okay, so your domain is the set of x values. When you're looking at the x-axis, it's going left to right. So if you're going from left to right, if you look at your x values, do you guys see how you have this arrow here? Okay, that means it's going to keep going to infinity. Okay, if it goes to infinity on one side, and if it goes to negative infinity on the other side, usually what we say is that there are no restrictions for x, okay, or no restrictions on both of them in this case. And whenever there are no restrictions, your domain and range is all real numbers. Now that might be a phrase that you've heard before, all real numbers. Okay, maybe you wrote it like this, maybe you wrote it out all in words. Today we're going to learn how to write it in set builder notation. Okay, so set builder notation is fancy. So first we have the domain and range. We're just going to start with a D and an R. Okay, when you're doing the set builder, we're going to do these fancy brackets that look like this. Or maybe did one of your teachers call them like braces? Yeah. Okay. I always say, because some people are like, I can't do that. And I'm like, you know what? You guys remember when you were young, did you used to draw pictures and there was the ocean and then you drew like these seagulls in the sky, these beautiful seagulls? You just turn them to the side. Those can be your brackets. Okay, so sideways seagull, that's fine with me. Okay, just do your best. All right, so your domain is going to be x, and then there's this line, okay? That line means such that. So this is x such that x is an element in the real number set. Okay, and I know some of your heads are exploding right now, that's okay. What this means is x such that X is an element, so it's this E value. That means it's an element, and then we're using the real number symbol, which is a capital R with a line through it. So this E is element, this is real number. Okay, so for some of you those words seem familiar, for others of us, you might have to keep reviewing this a little bit. And then for the range, it's also going up to positive infinity for the y's, because the arrow up means I'm going to positive infinity. The arrow down here means you're going to negative infinity. So y is also all real numbers. This will happen every single time you have a straight line. Anytime you have a straight line, the domain and the range are both all real numbers. Okay, now for B, if you are looking at your arrows here, okay, on your x's, this means that your x value, even though it's going to be really slow, on the x it's going to go out to infinity. It's just going to take a really long time getting there, and it's going to go to negative infinity. So there's no restrictions on the x. And whenever there are no restrictions, we are just going to write all real numbers and set builder notation. Okay, so we're going to practice writing that again. And I want you to look at the y's. So the y's are going to have restrictions. I want you to try to find the lowest y value and the highest y value. Okay, so I want you to look at that, and I want you to say to yourself, what is the lowest y value? What is the highest y value? Okay, so with your values, what's your lowest y value? -2. Great. So we're just going to draw a line. I think it's really important that we make this visible so when you're looking back, you understand where the answer is coming from. So -2 is the lowest. The highest is these arrows. So what do we call that? Yep, infinity. So the way that we would say that, okay, in words is that all of the points have to be above -2. So y values are above -2. So all of the y values are above -2. So we start this the same. We say y and then the line, which means such that. And then do you guys know what symbols we can use to show that it's above -2? The greater than? And then is it greater than or greater than equal to? What do you guys think? It is greater than equal to, and that's because it does actually hit that point, so we want to include it. Okay, great. Okay, so you can use inequalities here. So it's y such that all the values of y are going to be above -2. Okay, great job. So I want you to do part C. If you want to try that on your own and then check in with your elbow partner, that would be great. And then I'll be coming around today and just asking you guys if you prefer sitting at the front or the back of the room. That way if you need to sit closer to the board, I know. And sometimes I feel bad putting people in the back if they don't want to be in the back. So if you like to be in the back, just let me know. All right, so what did we get for the domain for C? Were we able to do that? I see lots of you have it. What did you guys put? Oh, real numbers. Yes, yes, yes. Okay, so there's no restrictions for the x's, right? You have those arrows in both directions. Okay, so your domain is x such that x is an element in the real number set. Okay, and then for your range, all of your points are above what number? 1. So it's y such that y is greater than or equal to 1. Y is what? So like this will be your 1. So all of the y values, this will be the lowest one. The highest one will be infinity. And so it'll be y is greater than or equal to 1. So kind of similar to this one, right? How all of them are above -2.
But then why is the other one not?
Oh, because, okay, so for the x's, we're going to look left or right. So if you're looking out to the right, yep, this arrow just means that it keeps going. So this will keep going. So this will be infinity. And then this side will be negative infinity. So you'll switch from left to right to up and down. All right, and then example 2, it says this table is going to show us the number of raffle tickets sold for the first 6 hours of a country fair. We have to define the domain and range. So when you're looking at a table, is the domain usually the first row or the second row? The first. Okay, so this is our domain, this is our input. Okay, and then this is our range, this is our output. Now, this is a little bit different than when we had it with the graph, because the graph includes all these points in between these whole numbers, right? Like this includes 1.5, 1.6, 1.7, but your raffle tickets, you aren't going to sell 14.5 raffle tickets. So the way that we write these is going to be as a list. So the domain is just going to be a list of your x values. Generally, they will be in numerical order. And what's nice for us is they are listed in numerical order. So 1, 2, 3, 4, 5, 6. And then we separate those elements with a comma. And then same thing for the output, your range. If they aren't in numerical order, I'm not going to mark it wrong. I'm just letting you know generally how those will be written. Okay, and then you have your brackets that notate your set. Okay, and then for example 3, it says determine whether each function is 1-to-1. In order to do this, you're going to use the horizontal line test. Okay, so use the HLT. Okay, so we wrote above, if it intersects in more than one point, it's not 1-to-1. Okay, so it's if you can find any place on the graph where it intersects in more than one place. So if I can, usually I take like my pencil and I just say, yep, if it crosses 2 places, then it is not 1-to-1. And so all you have to write for this is not 1-to-1. Okay, so really everything we've done today, there's not going to be work to be shown per se. Okay, you're just going to have to make sure you understand how you're getting to your answers. The second one's a little tricky because it kind of looks like there might be 2 places here, but it's just with the pixels that we have, this is going to continue to go up. So this is a 1-to-1 function. This is a cubic function. Okay, if it is a place where it crosses 2, you will see it flat like this. Okay, it'll be obvious. Now, what about this? Do we think this is 1-to-1 or not 1-to-1? No, because it intersects an infinite amount of points. Yeah, it is the horizontal line, so definitely cannot be 1-to-1. All right, great. All right, and then the last thing we're going to talk about about today is continuous functions and discrete functions. Okay, just nod your head if a continuous or discrete function is something you've heard of, even if you don't remember what it is. Okay, so if it is continuous, you can graph it with a line or an unbroken curve. I think a good way to remember it is that you can draw it without picking up your writing utensil. And if it's discrete, it has to be discontinuous, in which the points are not connected. Okay, so example 4 says to examine these graphs and determine whether it's discrete, continuous, or it can be neither. Okay, it does not have to be one or the other. And then we're going to state the domain and range of each function. Okay, so the first thing I want you to do is I just want you to pick out, so I'll give you a hint. There's one of each of these, and I want you to label which one is which. So there's one that's discrete, there's one that's continuous, and there's one that's neither. So I want you to go ahead and label those for me. All right, number 1 is what? Continuous. Number 2 is discrete, which means the last one, neither. So that has pieces that are continuous, but because they're not connected, that's why it's going to be neither. Okay, and when we do the domain and range for this, we're going to have to look at each piece separately. So that's going to be a little bit different, okay? So if it is continuous and it is a vertical line, there is actually only one x value. What is the x value in this graph? 3. So when you plug in 3, you're going to have all of these different y values. So the domain for this is just 3. And just so you know, the book kind of alternates. Sometimes they'll put these dots. Sometimes they'll put an equal. It really doesn't matter to me which one you use. I use the dots more frequently, and I feel like that's what you'll see like going forward. But the book did use the equal to in example 4, which is generally I just try to follow that so that you aren't confused when you're doing the work. But again, you can pick, okay? Okay, now for the range, we're looking at the y's. What is the lowest y value? Negative infinity. Yep, the lowest y is negative infinity. The highest y is infinity. So when that happens, it's y such that y is an element of the real number set. So anytime you're going from infinity to negative infinity, it's going to be all real numbers. Okay, for the discrete, for the domain, because these are points, the discrete domain is just the x values of each point. So this is your x value, this is your x value, this is your x value. And again, we just try to put those in numerical order. So we're going to list them 2, 3, 4. And then we're going to do the same thing with the range, except we're going to be looking for those y values. Okay, and like I said, I'm going to put them in numerical order. I would not mark you wrong if you did 3, 1, -1, not a problem. Okay, this is just most commonly how you'll see the answer written when you go to check your answers, okay? All right, now we have some fun to do here. So when you have the two intervals, we are going to look at each interval separately. Okay, and we're gonna do the domain first. So when you do interval notation, okay, there are a few things that we have to know, and that's when you have a closed circle, you're gonna have a bracket. And then when you have an open circle, it will be parentheses. And I'll write that down in a second for you on the side. But what we're going to do is we're going to look and see where on the X this is going to go. So if I show where this hits on the X, we can see it's 1, 2, 3, -4. And then that's going to go to 0. Okay, sometimes I write them above here so you guys can see it goes from -4 to 0. So the way that we write that in interval notation is -4, 0. Okay, so we have -4, 0 here. Okay, and then because we have two intervals, we have to use this symbol. Do you guys know what that symbol means? Yeah, it's the union. Okay, so you may have studied Venn diagrams a long time ago and talked about like the two sets. That's usually where those come into play. Okay, anytime you have two intervals, they connect with a union. So this is what you're going to have to use if it's neithers. So intervals connect with a union. This is a good reminder to write down because I know that this is new for you. And then if you want to see if you can write down the other interval, that would be a good test to see if you understand how we're putting those together. Okay, so see if you can find the X values for that second interval. And we are going to be putting those in brackets. Oh, I guess the first one here. Okay, so for your X value, your first X value, you're here at 1. Okay, and then do you guys know what this arrow means? Infinity. So we are going to put infinity here. And if you put a bracket, I'm sorry, let's fix it. I feel like I led you to believe that was going to. Okay, anytime you have infinity, you are going to have parentheses, and that's because infinity isn't a number, it's an idea. Okay, it's not an exact number. Okay, so if you have a bracket, that means you have a closed circle. That means it's inclusive. Okay, so brackets will have closed circles on your graph. And then parentheses are going to have an open circle. It's parenthesis. That's how I remember. Okay, and that's an open circle or an infinity. It doesn't matter if it's positive or negative. So parentheses are going to be if you have an open circle on the graph or if you're going to infinity. Okay, so you have the arrow. Okay, so we were just looking from left to right. For the range, we're going to have to look up and down. Okay, so what we're going to do is you have to start with the lowest y value. Okay, so if I'm looking at this scale, right, the lowest y value is what? Negative infinity. Great, so we'll put that with a parenthesis. Oh, and it's okay if your negative infinities aren't shaping up so great yet. Yeah. You can also do like two circles next to each other, like that. Yeah, you can do that as well. These remind me of the little goldfish I would make when I was little, you know, when you were drawings. Okay, so negative infinity is the lowest, and then from there, you're going to go until there's a gap. So you have negative infinity here, and then see how you reach a gap point there? Okay, so that's going to be -3, 1, 2, -3. And then because that's a closed circle, we're going to put a bracket. And then I want you to try to do the second one. See if you can put that in there. All right, looks like this one's going pretty good. So what was the lowest y value in the second interval? -2, and then that goes up to 2. Yep, so if you're having trouble with that, a great thing to do is to just follow this here. So that's -2 up to this point here, which is 2. And this is our y's. Okay, so that's going to be your domain and range. Okay, and I know that that is enough math for today because we learned some new things, and I want to give you some time to practice those today. So I just need your attention for a few more minutes because I'm going to show you a few things that are going to be a little different.